Hello, dear viewers. Welcome to our channel, Mr. Andrew from Andhra. Learn with joy. In this video, we are going to discuss about trigonometric ratios of complementary angles. So, what are complementary angles? If the sum of any two angles is 90 degrees, then they are said to be complementary angles. In this triangle, angle B is 90 degrees, which is marked with the red. Then angle A and angle C are complementary angles. So if you want to find angle C, then we can write it as 90 minus A, because angle A plus angle C is equal to 90 degrees. Let us recall the basic definitions of trigonometric ratios. So we can write sine as opposite on hypotenuse, cos as adjacent on hypotenuse, tan as opposite on adjacent. So we can derive the values of complementary angles by using a right angle triangle. Suppose if you consider angle A as alpha and angle C as theta, the side AC as B, because that is opposite to angle B, side BC as small a, and side AB as small c. So we can write alpha as 90 minus theta, because as we discussed in the beginning, because the sum of angle A plus angle C is equal to 90 degrees, since angle B is 90 degrees. So we can write sine theta as C on B, which is opposite on hypotenuse. But if you want to write cos alpha at the same time, that is also C on B, because for alpha, the adjacent side is C and the hypotenuse is B. So we can write cos of 90 minus theta as C on B. So if you club them together, we can write cos of 90 minus theta as sine theta. See there, sine theta is C on B and cos of 90 minus theta is also C on B. Then we can consider that cos of 90 minus theta as sine theta. Similarly, we can write cos theta as A on B, adjacent on hypotenuse. At the same time, we can write sine of 90 minus theta as A on B, that is opposite on hypotenuse. So for alpha, the opposite side is A. So here also we can consider that sine of 90 minus theta is equal to cos theta. In the same way, tan theta is C on A, and cot of 90 minus theta is equal to C by B, so that cot of 90 minus theta is tan theta. It's easy, right? All students, take care. What is that? Have a look at the highlighted letters A, S, T, C. All students, take care. What is that? Let's have a look at that. So if you observe in the coordinate system, so we have four quadrants: first quadrant, second quadrant, third quadrant, and fourth quadrant. So if you observe the behavior of these trigonometric ratios, in the first quadrant, all are positive, means all the trigonometric ratios will give the positive values if you measure the angle in the anti-clockwise direction. Similarly, in the second quadrant, sine theta and cosecant theta are positive. See, only these values are positive in the second quadrant. So the second quadrant will give the values between 90 and 180. And in the first quadrant, you see that the values lies between 0 and 90 degrees. And if you observe the third quadrant, only tan theta and cot theta are positive, and remaining values are negative. So in the third quadrant, you can see only the values between 180 and 270 degrees. Similarly, in the fourth quadrant, cos theta and secant theta, only these values are positive. Remaining values are negative. So A stands for all, S stands for sine and its reciprocal cosecant, T stands for tan theta and cot theta. So since cot theta is the reciprocal of tan, and C stands for cos and its reciprocal secant theta. So it's very easy to remember by using that word all students take care, right? So have a look at this. All students take care. A stands for all, S stands for sine, T stands for tan, C stands for cos. And you also can see their respective quadrants. So as a summary, we can say that sine of 90 minus A as cos A, cos of 90 minus A as sine A, tan of 90 minus A as cot A. Likewise. Here also, sine of 180 minus A as sine A, cos of 180 minus A as cos A, tan of 180 minus A as tan A. Okay, these are the relations of supplementary angles. So we can easily remember all these values by using a simulation. You can see a simulation by using this link. I will share the link in the description. So we can see a beautiful simulation which is related with trigonometric ratios and their behavior according to the given quadrant. So for example, if you want to observe the relation of cos, so you need to just move this cursor like this. So it will give you the value of angle, whatever chosen angle here. So for example, if I want to find the value of 60 degrees, cos 60 degrees, yeah. See that is, you know that cos theta is 1 on 2, that is 0.5, 0.5. And the value lies in the first quadrant here, so that it is positive. See for cos. Similarly for sine, tan. So you can change the angles like this. So now let us see in the second quadrant. Let me try for 120. So if you click on the special angles, it will also display the special angles here. See, for tan 120 degrees, the value is minus root 3. So let us try with sine. See, this is 120 degrees. Since it is in the second quadrant, the value of sine is positive. So sine theta is here root 3 by 2. Means for sine 120 degrees, it is root 3 on 2. And it is positive. So let us see for cos. So this is minus 1 on 2. Since cos is negative in this quadrant. So similarly, we can have a look at the third quadrant. See, cos 240 degrees is negative half. Sine also negative root 3 by 2. And if you observe the tan, that is positive because this is the third quadrant. Now let's have a look at the fourth quadrant. See here for angle 300 degrees, the value of tan is minus root 3. And cos 1 by 2, see it is positive because this is lies in the fourth quadrant. Similarly, sine, yeah, this is also negative root 3 by 2 because this is lies in the fourth quadrant. So similarly, we can relay these relations to their reciprocals also. Means you know that secant is the reciprocal of cos, cosecant is the reciprocal of sine, and cotangent is the reciprocal of tangent. So it's easy, right? We also can have a look at the wave behavior, okay, below this picture, right? Below this animation. Even though you can convert the angles into radians if you want by clicking on the radians tab here. So it's very friendly user. So please use the link given in the description and have a try on this animation. Then it's very easy to remember the trigonometric ratios and their behavior according to the quadrants.